So first of all, let us write down the molecular formula C10H12O2 from the problem itself. Therefore, we calculate an index of hydrogen deficiency of 5. The infrared spectrum, the carbon NMR spectrum, the proton NMR spectrum, all of the three suggest the presence of an aromatic ring. That is an index of 4. The remaining index of 1 is attributed to a C double bond O group found in the infrared spectrum at 1711 centimeter inverse. This value for the C double bond O is what we might expect for an unconjugated carbonyl group, but not in ester since it is very low, instead in ketone. The same here, carbon NMR, it confirms the presence of a ketone. This peak at 207 is indicative of a typical ketone. The carbon NMR 1, 2, 3, 4, 5, 6, 7 and 8. It shows only 8 peaks. While our molecular formula contains 10 carbons. So this suggests probably some symmetry that makes some of the carbon equivalent. Let us see this proton NMR. In between 6 and 7, 6.8 to 7.2. There is a nice para substitution pattern which appears as a nominal pair of doublets integrating for 2 protons in each pair. You can also notice that the upfield portion of the spectrum has protons that integrate for 3:2:3. That is a CH3, a CH2 and again a CH3. Also, carefully if you will notice, the upfield portion at 3.8. This is 3 here. 3.8. I'm sorry, the downfield methyl at 3.8 around here is next to an oxygen, which suggests a presence of methoxy group. Peaks are also unsplit, which indicates no neighboring protons are present. The DEPT NMR spectra result, it confirms the presence of 2 methyl groups and 1 methylene group. The methyl group at 55 is de-shielded by the presence of OCH3, of oxygen from this OCH3. Now here we saw that there is para substitution. So keeping in mind all these things, para substitution pattern and the singlet peaks in the proton NMR, we derive a rough structural formula. An aromatic ring along with O CH3 and D and E having 2 protons So probably this is E and D pair. CH2 at B, CH2 over here at B, at B, a C double bond O near A CH3. This is the probable structure. We will confirm it using DEPT 135 and DEPT 90. The presence of 4 peaks in the aromatic region of carbon NMR. 2 of the peaks we can see at 126 and 159 are ISPO carbons, that is no attached protons, that do not show in DEPT 135 or DEPT 90 spectra. The remaining 2 peaks of 114 and 130 ppm, they are assigned to remaining 4 carbons which are equivalent symmetry. The 2 carbon atoms D show peaks both of DEPT experiments, which confirms that they have attached protons CH. Likewise, the both carbon atoms at E have peaks, this is positive, positive have peaks in both the DEPT experiments, confirming the presence of CH. In this infrared spectrum again, here at 835 centimeter inverse, we can see a para substitution pattern in the out of the plane region. This helps us to confirm 1,4-di substitution on this aromatic ring. Hence, this structure, it is been found using trial and error method, is hence found to be correct. When we name this compound, it is called as 4-methoxy phenyl acetone.